Hi, this video is going to go over lesson 4.4 in Envision, and this is on expanding expressions. I'd like to start on page 207 and look at the solve and discuss it. The school is planning to add a weight room and a gym. If the total area of the gym and weight room should stay under 5,500 square feet, what is one possible length for the new weight room? Show your work, and are there lengths that would work? Why not? Yeah, anyway. So this problem is really about area of this floor plan, and you should already be able to figure out, first of all, we should remember that area is found by doing the base times the height, or we can say, or instead, since it's a rectangle, we could say the length times the width. So if you notice here, you know that the gym, you already know the length and the width. So you should be able to find the area of the gym. What we don't know is how big is the weight room. So we don't know how wide it is. We know that this right here, the length, is the same as the gym. So that means this right here, this side should also be 55. So the question is, what number could this be so that it would stay under 5,500 square feet? Well, there are a couple of different ways of solving this. So why don't you pause that and solve? And now that you're back, let's look and see what answer you had. You should know there's more than one answer because we want to stay within a certain amount. So if I made this 1 foot, that should work. This is only 1 foot wide. Then there should be enough for but that wouldn't make any sense, would it, to have a weight room that was 1 foot wide? You wouldn't even be able to fit in it. So it probably has to be more than 1 foot. What if it was 6 feet? Well, if this was 6 feet here, how would I find the total area of the room? Well, I know to find the area of this part of the room, of the gym part, I'm going to do the length times the width. And the length is 90, and the width is 55, or vice versa. Or you considered, maybe you thought this was the length and this is the width. It doesn't matter. They're interchangeable here. So the area of just this room would be 4,950. So this is already 4,950. That means I don't have that much left over that this weight room could be. So what happens if this weight room is 6 feet? Well, then I would find the area of the weight room by doing length times width. So I would do, I said 6 times 55, and that equals 330. Well, 330 added to this number here isn't going to exceed the limit. So what's the highest we can go up to? Well, what happens when we put 10 here? Now we have two ways of figuring out this area. We can either do what we did before and do it in pieces and find you can find the area by finding the length times the width of the gym, and then add that to the length times the width of the weight room. Or another way to do this would be, we could just combine this whole side and say, well, this side here, if I make this 10, is 100 times the width of 55. So we find that either way, when we do this, our answer is 5,500. So that tells us that this right here, this number, x, has to be less than 10 in order for it to stay under 5,500 feet. But I want you to keep a close eye on these two different strategies. One, where we multiplied it in pieces, and the other one where we added these two things together first and then multiplied by the other dimension. And let's look at another example. So here's another area problem, and it says a family farm plans to add a blueberry patch to the end of the apple orchard. What is the total area that is covered with a blueberry patch and the apple orchard? So that means that we're going to be combining the areas of the blueberry patch and the areas of the apple orchard together. Well, do we know the area of the apple orchard? Does it tell us? No, but it does tell us that we know the dimensions of the apple orchard, because this dimension here is 2.5 kilometers, and this dimension over here is 1.5, because it's the same as this side. So I know I can find the area of the apple orchard by doing 1.5 times 2.5, and that'll give me the area of that piece. I also need to find the area of the blueberry patch. Well, the problem with that is there's nothing here. They don't tell us this length. So I'm going to give this a variable. I'm going to say, well, whatever it is, it's a number. And I know to find the area of this rectangle, I'm going to multiply this side here times whatever this side is. So I'm going to multiply 1.5 times the other dimension, which is x. So there, I know to find the total area, I would have to find the area of each piece and then add them together. Well, that's at least one way to do it. Another way to do it would be to imagine that this entire thing, this entire patch, was all one big rectangle. And so this side here would be 1.5. Oh, I put that decimal in the wrong spot. Sorry. So try again. This side here is 1.5. That's better. And then times this bottom side here. Well, I know it's more than 2.5. It's whatever this is plus this. So this x plus this together, if I added the x dimension, whatever it is, like pretend that's 7. I would do 7 plus 2.5 to get that side, but it's not 7. And I'm going to add that to 2.5 to get that whole side. And so once I add those together, I could multiply by 1.5. So these two expressions would give us an equivalent result. Here, I can either find each area and add them together, or I could make this one big rectangle first by adding the side together, two sides together, and then multiplying by the other dimension. But those are two ways of getting the same answer. That's what's called, this right here is called expanded form, and this is called factored form. So we're going to look at how we can go from one form to the other today. So here in the book, it's using b for this blueberry patch side and saying, okay, b plus 2.5, that's the base, and then multiply by 1.5, that's the height, and that's going to give us the area. But they're saying, if you notice, both rectangles, both this one and this one, are being multiplied by 1.5. So it's being distributed. That's called the distributive property. So that's the way it's being described in your book. Let's look at another example. So we're going to look at this try it, and the try it is asking us just to expand. So what this means is, and if I want to draw another rectangle, I don't know if it's worth it or not, but I'll just do that real quick. Let's say this is 3.6 over here. I know that this side is 3.6. And I'm going to break this rectangle up into two pieces. This, I don't know how long this is, but from here to here is 5. So what it's saying is to find the area I would multiply 3.6 times both t and 5, or t plus 5. 3.6 times t and 3.6 times 5. And then I could add it together second. So the way we look at it here is what I'm doing is distributing this 3.6. I'm going to do 3.6 times t and 3.6 times 5. I have to multiply the 3.6 by both of the terms in the parentheses. So that would be 3.6 times t and 3.6 times 5. Well, 3.6 times t is just 3.6t. 3.6 times 5 is 18. Now I can't add this term with the t in it to this term with the 18 in it. But you can see that's really the same thing as adding this area and this area together. So that's called expanded form. We're expanding it. We're actually expanding it out. Let's look at another example. Before we do that, let's just make sure we kind of summarize. We are going to be multiplying the number on the outside of the parentheses by each of the terms inside the parentheses, even if they're negative. So we're going to take the number on the outside of the parentheses, and let's say I have something on the inside. I'm going to multiply the number on the outside by everything on the inside. So 3 times t and 3 times 4, 12. And that's how we're going to expand. So let's look at this example, and your book is already worked out. See how they have, this time, they have an x on the outside the parentheses. So we had some other things like, we had a number like 3.6 on the outside the parentheses. It was like t plus 5, remember? Okay, and so this time they have a variable on the outside the parentheses. What's different about this example is they have a variable out here instead of a number, but they still treat it the same way. Watch. They're still saying x times negative 2 and x times 0.5y. So the next part here shows that they are multiplying x by both of those things. Then this next line shows that they are simplifying it. They're putting the coefficient in the front, and they are putting the variables in order from like alphabetical order. The one thing they did that we didn't talk about is they changed subtract here to add, and they changed this to a negative. So that's plus negative 0.5. So there's still a plus here, and they have negative 0.5 x and y. Finally, the last step is they got rid of the double signs. And so here you have it. So what I would have done is I would have just done x minus 0.5y and said x times negative 2, that's negative 2x. X times 0.5y, that's 0.5xy. And then this subtraction symbol goes between them, just like that. And that's how I would have done that problem. So what's the same about this example and the try it? We're still multiplying the whatever it is, the term on the outside the parentheses by everything on the inside. So let's do this one here. We are going to multiply the letter. This is your try it on page 209. You're going to multiply t by each of the terms in the parentheses. So I have t times negative 1.2w and t times 3. And then the next thing I'm going to do is kind of clean this up. And notice how we just put the variables in order from an alphabetical order, and we put the coefficient in front of the letter. And that's it. That's how you do this. That's how we expand. So now, without looking at your book, cover this problem up, and it says negative 1/3 times and inside the parentheses is a 2 minus 3x plus 3. And without looking, and after you, in a little bit you're going to pause, and I want you to try this and try to simplify this expression without looking in your book. So go ahead and pause now. Okay, so there's two ways of doing that. So let me show you what the book has, and now you can look at the book. So the book has two ways of simplifying the expression. The one is probably what I think most of us would do, is you would multiply the negative 1/3 by each of the terms in the parentheses. So negative 1/3 times 2 and negative 1/3 times, now they made this plus a negative 3x, so negative 1/3 times negative 3x and negative 1/3 times 3. So they did, and now they're going to actually multiply. So this becomes negative 2/3, negative 1/3 times negative 3 becomes 1. So then this is just x, 1x, the invisible 1. And then negative 1/3 times 3 is negative 1. But now I realize I actually have like terms, negative 2/3 and negative 1. And so when we put them together, I don't understand why this should be like plus negative 1. Anyway, so that's why we have this as the final answer when you combine your like terms. So that's one way to do this. The other way is to simplify what's in the parentheses first. And notice that there are like terms. So they could have combined those like terms together first and gotten 5. Then, and then kept the subtract 3x. Then the next thing, change subtract to add, and the second number to its opposite, I would have negative 1/3 times 5 and negative 1/3 times negative 3x. And when I do that, I get negative 5/3. And when I do negative 1/3 times negative 3, I get positive 1, the invisible 1x. So either way, whether we simplify and combine our like terms at the end or combine our like terms at the beginning, either way we get the same result. Voila. And then we will do the try at the bottom of the page. Now, it says here, why are we not able to simplify the expression in the parentheses first? So this is negative 2/5, by the way. Well, if I look inside the parentheses, none of these terms have a common variable. So they're all distinct. They're not like terms. So I can't simplify it any further than it is. So to expand, I'm going to multiply the number on the outside by the 10, negative 2/5 times 15m, negative 2/5 times 20n. And if you want, you can change subtract to add and this number to a negative. So now you have negative 20n. So I'm going to do negative 2/5 times 10 and plus negative 2/5 times 15m and negative 2/5 times 20n. So go ahead and do that and see what you get. Okay, welcome back. And I have, so this is negative 4 plus, and this should be negative 6m. And then this would be positive 8n. So if I want to clean this up a bit, I would have negative 4 minus 6m plus 8n, and that would be the expanded version of this factored version. How'd you do? Hopefully you got it right. So the last thing we're going to do is look at these two practice problems on page 211. It has the boxes here, so sometimes that can be confusing for us, so I wanted to show that one with you. But these boxes are actually pretty good. So to expand, I'm going to multiply the number or variable that's on the outside of the parentheses by each term inside the parentheses. So I'm going to do 3 times n and 3 times 7. So 3 times n and plus 3 times 7, 3 times 7. So if I simplify that, 3 times n is 3n, and 3 times 7 is 21. So there is the answer, number 7. Try number 8 and pause. Okay, you're back. So I'm going to multiply the number here, or whatever's on the outside of the parentheses, by each of the terms on the inside. So 4 times x and 4 times 3. So that's 4 times x and 4 times 3. And then I'm going to bring the subtraction symbol down because that goes between the numbers. So now 4 times x is just 4x, and 4 times 3 is 12. And there you go. You've expanded. So that's how you do it. To expand, you just multiply the number on the outside of the parentheses by everything inside the parentheses, and then simplify if you need to. Thanks.